વિદ્યાર્થી મિત્રો, લક્ષ સ્કૂલ ઓફ સાયન્સ બામણમાં ઓનમાં ફરી એકવાર આપણું સ્વાગત છે. આજે આપણે થોડીક સ્કૂલની યાદ કરીશું. ઘણા દિવસ થઈ ગયા સ્કૂલ જોઈને. આપણો ઓનલાઈન અભ્યાસ ચાલી રહ્યો છે. થોડીક સ્કૂલની માટીની સુગંધને અહીં આપણે જોઈશું તો મજા આવી જાય. તો ચાલો સ્કૂલની ઝલક જોઈએ. આપણું સ્કૂલનું આ સિમ્બોલ, આપણી આ સ્કૂલનું બાહ્ય દેખાવ કેટલો સુંદર છે. જો ભારત માતા સાથે આ આપણું એન્ટરન્સ. અહીંથી તમે અંદર સ્કૂલમાં વારંવાર જાઓ છો અને યાદ આવતી હશે બધી. કેટલું સુંદર અહીં લાગી રહ્યું છે. આ આપણે હોલમાં બેસીને પ્રાર્થના કરીએ છીએ, ભેગા થયા છે, મિટિંગો યાદ આવે છે કશું? હાલના શબ્દો નિલેશભાઈ ને આપણા વાતો બધી તો બધું મિસ કરી રહ્યા છે. તો થોડુંક આજે આપણે એને દિલથી યાદ કરી લઈએ એવી ઈચ્છા થઈ. જાત જાતની એક્ટિવિટીઓ આપણે કરીએ છીએ. આ બધું ખૂબ જ યાદ આવતું હશે. પ્રવાસો હવે તો આ વર્ષે ભૂલી જવાનું છે. આ બધું રમતો સ્કૂલને આ રીતે આપણે યાદ કરીએ અને પછી ભણીએ તો મજા આવશે. Welcome back, dear students, to Lux School of Science, and we are learning biomolecules lesson number 14. That will be the last lesson of your syllabus, and here we are going to complete syllabus. Dear students, what we are talking of is now glucose. Yesterday in previous video we have discussed about the structure of glucose, and in structure of glucose we have derived the structure of glucose in this manner by calculating that carbon, 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 carbon. 6 carbons are there, and in these 6 carbon, the first carbon has OH aldehyde, and that we used to speak as a CHO. The second carbon OH, H, H, OH, OH, H, OH, H, and last carbon is CH2OH. So this is our structure of glucose. So in this structure you will find that OH, fifth number carbon, has OH right side, then this is known as D-glucose. If OH is left side, then this is known as L-glucose. So this is our simple talk, C12, C6H12O6. This is the glucose structure. Now in this structure, some problems arise. What? Here we are finding that aldehyde is separated. Okay? As aldehyde is separated, then it should be give the reaction with Skiff reagent. Okay, so first thing is it is not reacting. Do not react with Skiff reagent. So first problem what we are getting with this is it is not reacting with the Skiff reagent. Do not react with the Skiff reagent. That is the first problem. Second problem, do not give addition reaction with NaHSO4, NaHSO3. Generally, sodium hydrogen sulfide, when react with the aldehyde, then we are getting addition reaction of hydrogen cyanide. Addition reaction of hydrogen cyanide. So here we are not getting addition reaction of hydrogen cyanide. That is the second problem. So here question arises whether there is an aldehyde or not. Because if it is aldehyde, then it should be react with the Skiff reagent. If it is aldehyde, then it must give the addition reaction of hydrogen cyanide with the NaHSO3. Okay. Third one, if we will go. So yesterday when we were talking about structure of a glucose, at that time we had got pentaacetate. So this pentaacetate, what we are getting there, pentaacetate, this does not react, does not react, do not react, this do not reacting with hydroxylamine. Hydroxylamine. They are not reacting with hydroxylamine. That is another problem. So these are the first problem. Do not react with skip reagent. Do not react with the NaHSO3 to give addition of the hydrogen cyanide. Also, it is not reacting with the pentaacetate what we are getting yesterday. These are not reacting with the hydroxylamine. So that was the problem. Moreover, another problem is that glucose has another two structure. One is the alpha glucose. One is the alpha glucose. Now, how we get to come about the alpha glucose? So, dear students, generally when we boil some substance with the water and then we glucose it, okay, and the water is removed, at that time the crystallizations occur, and due to that crystallizations we are getting the solid substance. When we are doing such thing that with the glucose, here instead of one crystallization we are getting two type of crystallization. One, see, when we heat this thing with the 310 Kelvin temperature, okay, so when 310 Kelvin temperature the glucose water is boiled out, then we are getting alpha glucose. How we come to know? Because its melting point is 319 Kelvin. Okay, so from that we are getting idea that these are the different, because its melting point is 319 Kelvin. Another structure we are getting is beta glucose. So there is a beta glucose also, and this happen when we heat with the 371 Kelvin, and its melting point is, sorry, here 490, and its melting point is 423 Kelvin. So melting points are different. One has structure 419 Kelvin melting point, other structure has 423 Kelvin melting point. And how it is, after boiling 310 Kelvin we are getting alpha structure, and after boiling with the 371 Kelvin we are getting the beta. Now these alpha and beta structure cannot be explained here, and that's why we found that something wrong here. So these 4 points you have to remember. First point, do not react with the skip reagent. Second point, do not give addition reaction with the sodium hydrogen sulfide. Pentaacetate do not react with the hydroxylamine, and alpha glucose and beta glucose are obtained. Okay, alpha glucose melting point is 419 Kelvin and beta glucose melting point 423 Kelvin. How alpha glucose is prepared? By boiling 310 Kelvin. Okay, it is when crystallized, then the alpha glucose is obtained, and by boiling the glucose at 371 Kelvin temperature, we are getting the beta glucose. So this is the problem, and this problem will not satisfied by this structure. So now we are forced to find out another structure of glucose, and this another structure of glucose, now it is known as cyclic structure. So now we are going to talk about the cyclic structure of glucose. So if we will represent glucose as a cyclic structure, then straightway yesterday's our calculation that when glucose react with the hydrogen iodide, it is giving N-hexane. That's why glucose has a linear structure. That is abolished out. So now what to do? So that's why scientist has made one trick. Okay, as in benzene ring, the double bond are one side, this side kind of, this kind double bond, okay, and second time this, this. So they told that, okay, this has resonance structure in tandem. Same thing here, they have given that linear structure and cyclic structures are in resonance. Okay, so they are arranged in this pattern. Actually, now what is happening here? Fifth number of carbon. This is first, second, third, fourth, fifth, and sixth. Actually, yesterday we discussed that fifth number of carbon, that is going to attack on, that is going to give difference. Now it is fifth number carbon, OH is right side, that's why it is D-glucose. So this is going to attack on the aldehyde, and due to that reason we are having now different structure. Now here C, 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 C and CH2OH. There is nothing change in CH2OH. Okay. Now here hydrogen is come here. So this become OH. And this H become like this. So H come this side and OH is octane. So here only O is remaining now. Other things are as it is. બીજા કોઈમાં કોઈ બદલાવ આવવાનો નથી. Everything is as it is. Okay. હવે અહીંયા ખાલી કોણ રહી ગયું છે? ઓક્સિજન. But we know that oxygen require double bond. ઓક્સિજન ને ડબલ બોન્ડ જોઈએ છે અને કાર્બન ને 4 બોન્ડ જોઈએ છે. તો આ કાર્બન સાથે 1 અને 2 થયા અને અહીંયા ખાલી આપણા પાસે ઓક્સિજન. તો આ ઓક્સિજન અહીંયા મૂકી દઈએ. આ બોન્ડ અને આ બોન્ડ આને અરેન્જ કરી દીધું. Now everything is satisfied and this structure becomes cyclic. So there is no presence of individual aldehyde here proved, and this structure is satisfying that 4 things, and this structure also satisfying the another thing. What to say? What is satisfied by this? So see here, number 1 carbon now. So number 1 carbon should have 2 structure. Another structure is this. C, 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 C and CH2OH. Here it is O. Okay. Rest of everything is remain as it is. H, H, OH, H, OH, H. Now here H is this side and OH is this side. So here we are getting another 2 structure. Okay. And these structures, if OH is left side and OH is right side, that will make the difference. And that's why OH is right side, it is known as alpha glucose. And OH is left side, that is known as beta glucose. So cyclic structure of the glucose, is satisfying the another 2 things that we have seen in that 4th step. Okay, alpha glucose and beta glucose, such things are there. So due to the number 1 carbon, such isomerism develop. So now in glucose further more as isomerism we are getting here. Okay. So here we are getting another isomerism due to the first carbon. Such isomerism is known as anomerism. So this is due to the number 1 carbon, glucose is getting 2 form, alpha glucose and beta glucose. These alpha and beta glucose are known as anomers of each other, and such isomerism is known as anomerism. So dear students, you understand the cyclic structure of the glucose. Okay, but when the glucose is furtherly studied out, at that time find that this cyclic structure is correct, but moreover this structure should be like the pyrene. Now what is the pyrene? So here we are going to discuss about the word pyrene. See, when such hexagonal pattern is drawn, cyclic structure, then double bond and double bond, such things are kept. This is known as benzene. Actually, this kind of structure is known as benzene. Here all are carbon, 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 carbon. All are carbon. But instead of this 6 carbon, 1 oxygen come out. Instead of 6 carbon, 1 oxygen is come out, and the rest of remaining carbon. Then such structure is known as pyrene. Okay. So this is the another thing. So here in glucose, just we have seen it's look like such structure. So let's study pyrene structure of the glucose. And in pyrene structure of the glucose, we are starting with the first carbon, carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, carbon number 6. And 5 number of carbon is joined with the first number of carbon by oxygen. Okay. So this is the structure of glucose. Now in this structure, carbon number 1 is having OH up, H down, H, OH, OH, H, H, OH, and here CH2OH and H. Okay, so this is our structure of the glucose. This structure is known as Haworth structure. So I hope that you understand this structure. Now here also we have to talk about the alpha and beta glucose. So let's study alpha glucose and beta glucose in the Haworth pattern or the pyrene pattern. Dear students, this is also known as glucopyranose. Now I have drawn this very complicatedly. Now very simple way I am going to give you the idea. So what you have to do? અહીંયા ઓક્સિજન લખી દો અને હેક્સાગોન બનાવી દો આ રીતે. પતી ગયું. પછી અહીંયા ઊભી લીટી એક, અહીંયા ઊભી લીટી, અહીંયા વર્ટિકલ લાઈન ડ્રો કરી દો. ચલો, here H OH, H OH, OH H, H OH, CH2OH H. તો આ રીતે દોરી દીધું. Now here OH is down. First carbon has OH down. Here first carbon has OH up. So this is the isomerism. Actually OH down is known as alpha glucose and this is D glucose. So alpha D glucose. And here beta D glucose. So glucose has nearby 6 isomerism. Alpha glucose, alpha D plus glucose, alpha D minus glucose, L D plus glucose, okay, beta D plus glucose, then beta D minus glucose. Same thing we will go with the L. So lots of isomerisms here glucose is having. So this is the stereochemistry and it is very interesting. So OH is down, alpha glucose, OH is up, beta glucose. So this is the structure of a pyrene structure of the glucose. Okay, so hope that you understand this structure very nicely. Okay, so this is structure glucose. Here we have confirmed everything about the glucose. Okay, how this is. So what you have to remember? Now enter I am giving BQ quick revision. So first, the linear structure of glucose was not satisfying. The first aldehyde is separate because it was not giving the reaction with the Skiff reagent, which is the conformation for the aldehyde, and that's why the structure of glucose in question. Second, the glucose was reacted with sodium hydrogen sulfide, which was not giving the addition reaction of hydroxyl. Second one, the pentaacetate produced due to that substructure was not reacting with the alkylamine, okay, hydroxylamine, Okay. Then after we have seen that the glucose has another isomerism, that is the anomers. How? So glucose has, if boiled 310 Kelvin temperature and it is crystallization, then this structure, these crystals was melted at 300 and 419 Kelvin, which is the one structure. This structure is known as alpha structure. Same thing if we talk about if the glucose solution is evaporated at 371 Kelvin temperature and then crystallized out, then we are getting the crystal which are melting on the 423 Kelvin, which is known as beta glucose. So glucose has another two structure, alpha glucose and beta glucose, that was not satisfied by the simple structure. So that's why the new structures, cyclic structures was established, and cyclic structures are given in two patterns, a square pattern and another pyrene pattern. Pyrene pattern structure is known as Haber structure. Okay, so this is our talk about the glucose, how glucose is fascinated into the alpha and beta structure, how it is fascinated into the Haber and Haber cyclic structures and linear structure. So here glucose is completed, and now we are going to talk about the fructose. But dear students, in flow, instead of glucose, fructose I will speak now glucose. Then you have to understand, now I am talking whatever, that is the talk of fructose, not glucose. ફ્લો માને ફ્લોમાં આપણે ગ્લુકોઝના બદલે ફ્રુક્ટોઝના બદલે શું બોલતા જઈશું? ગ્લુકોઝ બોલાઈ જશે. સો યુ હેવ ટુ ધેન થિંક ધેટ કે ઇટ ઇઝ નોટ અ talk of glucose, it is talk of only fructose. So fructose. So fructose is also important carbohydrate, and this carbohydrate is actually having the ketone group. So that's why fructose is known as ketohexose. Okay, so it is also known as ketohexose because it is having the ketone group. So this is giving us that glucose is nothing but the obtained from the same method when we have taken that sucrose is hydrolysis, it is giving the mixture of glucose and fructose. So this is the preparation of fructose, very simple, same thing there. Also we come to know that the fructose is obtained from lots of fruits which are very sweet. So okay, the fructose are getting by us in the fruits from honey, from the vegetables, okay, and very importantly fructose also giving us lots of energy. Okay, so fructose, its molecular formula is also C6H12O6, but it is ketofructose. That's why when we are talking about the structure, then it's in linear structure, second number of carbon is having the ketone group. So CH2OH, COO, COH, CHOH, COH, and last carbon is CH2OH. So total 6 carbons are there. Out of 6 carbon, first and last carbon is CH2OH, second carbon is C double bond O, that is the ketone group, and rest of as it is. Here also the fifth number of carbon will decide the isomers, and as fifth number carbon is having right side OH, this is known as D-fructose. So it means it is the dextrorotatory. If OH is left side, then this is known as L-glucose, and that is levorotatory. So glucose is also having same thing, fructose is also having same thing as a glucose. Okay, so I hope that you understand the talk about the structure of the glucose. Only second number of carbon is a carbonyl group, and that is the ketone, and this ketone will decided D or L glucose by the fifth number of carbon. So same as glucose. Now here, this glucose, this fructose is also not giving the reaction of ketone. That means what we have drawn here, this cyclic structure, this linear structure is not correct. So what is happening? So here again, this fifth number of carbon is going to attack on the carbonyl group. But here carbonyl group is not at first number. Here carbonyl group is at second number. And that's why now whatever the cyclic structure we are obtaining, so C OH અહીંયા અટેચ કર્યું, આ H અહીંયા જતો રહ્યો, then C OH H C H OH C. Now this is H remaining, અહીંયા જઈ થશે CH2OH. Now what is happening? અહીંયાથી H તો અહીંયા જતો રહ્યો છે, OH બનાવી દીધો આપણે. Okay, you are getting me? અહીંયા H OH બની ગયો, તો અહીંયા એકલો O રહી ગયો. So this O is going to attach with the first number of carbon like this, and remaining CH2OH I will write here. So this is the cyclic structure of fructose. આ fructose નો cyclic structure છે. Okay, so in this cyclic structure, here also now CH2OH and OH. OH is right side. OH is here right side. And if OH is right side, we used to speak that it is alpha glucose, alpha fructose. So this is the stock of alpha fructose. Now in this structure, OH is if left side. અહીંયા આવી જાત તો એ beta structure થઈ જાય. So here also we are getting the thing that how the glucose is in cyclic structure. Okay, so in cyclic structure, if OH is right side, it is known as alpha fructose, and its name is fructofuranose. Its name is fructofuranose. Now what? So now here we are going to talk about the same structure. When we were talking about the glucose, at that time we have taken pyrene structure. Same thing here, we have another structure with the oxygen. If the oxygen is attached with the 4 carbon in this pattern, cyclic pattern, this is known as pyrene. This is known as furan. 6 હતા ત્યારે 6 hexagon હતો તે furan, pyrene, અને pentagon એ furan. So it is nothing but the furan structure. That was pyrene and this is furan. So now we are going to draw the furan structure of the glucose, fructose. So furan structure of the fructose. Here you have to draw O. Okay. This pentagon you have to make. This is the furan. We will start with the carbon number 1, carbon number 2, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and up carbon number. So this is carbon number 6, CH2OH, niche H. Here also CH2OH, niche OH. Okay, rest of all same, OH, OH, H. Okay, so this is the structure of the fructose, and as OH is down, it is alpha fructose. Okay, so same thing you can draw, and OH is taken up, then this will be the beta fructose. So alpha fructose. So simple. વચ્ચે દોરવાનો આ રીતે દોરો. Okay, second number no carbon CH2OH. So total first number carbon 2, 3, 4, 5, 6 carbon. So this is the structure of the fructose. So I hope that you understand the structure of glucose and structure of fructose that we have studied today. And with this, we are ending the carbohydrate, because onwards we are not having any another thing. That means that disaccharides, polysaccharides, and also some natural compounds of carbohydrate. Okay, so these are removed from the syllabus, and this will be also not asked in JEE and NEET. So don't worry about that. We do not have any problem. Okay, so no question will be made from this, so that will be easy target for you. So carbohydrate departments here we are completing. From tomorrow we are going to start amino acid, after that amino acid, nucleic acid, and that will be the end of the lesson. Okay, dear students, so here we are going to ending the syllabus. Okay, keep it up, study nicely.